and hand over to you. Stage is yours, Tobias. Thank you very much.
Well, great. Thanks a lot. Yeah, also warm hello and welcome from me to today's installment of SAP Inspiration Sessions. My name is Tobias Eljasik-Swoboda, and I'm going to talk about ONTEC's Readiness Navigator and AI solutions. And well, today I aim to answer a few questions for you. So the first question I want to answer you is, who is ONTEC? Because I think we are not that well known, and I just want to share a little bit of information with you. The second question is, who is talking? So a little bit about my background, so you can put everything I say into perspective. And after that is out of the way, I want to start with the actual content of today. So the next question I want to answer is, what is readiness, and what do I mean by readiness when I'm talking about it? Which leads me to the fourth question about what is a readiness navigator. If we have that out of the way, I want to talk about AI readiness levels. And lastly, I want to talk about how to use AI to measure readiness. So this is what I aim to do today, and let's dive right in. So who is ONTEC? ONTEC is an individual software development company. We have been operating this market since 2001. And we also have an IT operations branch with typical hosting and SLA offerings since 2006. And what's relatively new for us is our machine learning and artificial intelligence branch, which we have since 2019. We have approximately 60 employees and are part of the Tech Gruppe. Tech Gruppe is a group of companies here in Austria of similar size. We have 5 companies, all in the IT area. And actually, we're your neighbors here in Vienna. So I'm talking to you from right here, and the entrance to your building is actually here. Google gets it wrong on the picture. So thanks for all the lunches in your cantina, which I get to enjoy frequently. We are also a partner of INITS. INITS is Vienna's high-tech incubator, and well, we were working together in the creation of the Readiness Navigator, which is part of our talk today. Well, about me, I'm Tobias Eljasik-Swoboda. I already mentioned that, and I have a relatively recent PhD in computer science with a research focus on explainable natural language processing, requiring few examples to learn new tasks. I did this PhD and my research part-time. I have professional experience in multiple Austrian and German companies working as systems engineer, pre-sales consultants, enterprise architect, and innovation manager. And especially this last role of innovation manager means that innovation management itself is near and dear to my heart. So in order to give an answer on what readiness means, which is what I want to do next, we first need a few core definitions, which I want to provide you with right now. So these core definitions, what are ideas, inventions, and innovations? I'm pretty sure we all have a concept of those words. They're not exactly new, but I want to define how we use them and what we actually base this on. So an invention is an idea. So this is not necessarily really positive. It can also be a falsehood or a lie. So it's possible to say to somebody, yeah, you just invented this. There's also an innovation, which means, an innovation, on the other hand, is a successful invention. Well, this means the innovation is actually problem solving and uses at least one invention to do so. And lastly, what does it mean for an innovation to be successful? Well, an innovation is successful if it's 3 things. It has to be profitable, ecologically acceptable, and socially acceptable. And well, I didn't just make this stuff up. There is actually a bunch of literature about this. And I added sources in all of these slides, so you can look it up later on. Okay, so having this out of the way, we get to the next part, which, sorry about that. My computer doesn't behave the way I wanted to. Which is a question, what are key questions for successful innovations? Well, the first question is the market ready for the technology? So this can also be read, will they buy it? It's nice if you have a great technology, but if you have no customers, it won't be successful. On the other hand, there's a question, is the technology ready for this market? So this can be read as, does it work and can I produce it? And there's a quite obvious sweet spot. Well, it means high technology and market readiness. And well, obviously, if you have both, you're in a good spot. But you have some problems on getting to the way there. So one of the key problems is how to synchronize the time and content of your technology and market development activities. What should you do first in order to ensure success? And also, quite interesting question is, how do you actually measure readiness? In order to answer at least this last question, how to actually measure readiness, I want to provide you with a brief history of readiness levels. The term readiness levels were defined by NASA, and they used it internally since 1974 and only published it in 1989. And what this concept basically means that is you have 9 readiness levels that express how ready a technology is for usage, beginning with basic research after you have identified the physical concept that you can use, all the way up to successful test, launch, and operations flying up to space. And these are NASA's 9 readiness levels with key gates in between of when to pass from one level to another. This was extended by the authors Dent and Petit, and they included a view on market readiness in 2011. And it's quite similar, providing a vision of how ready an innovation is for a market, or vice versa, how ready the market is for this innovation. Hasnauer et al. Built on this and created a framework to manage innovations, and this stuff was created in 2015. And nice about this framework, because there's quite a lot of different innovation management frameworks, to be honest, but this was actually tested on 57 startups and 26 high-tech product development projects in established companies, and had sort of a control group of other startups that, did not use this methodology in the time. And the great thing about it is that innovators using this methodology had a 30% increased chance of success. So success here means they didn't have to shut down their startup, and 60% increased chance to export. And yeah, it means what it means. After this, we at Ontek packaged this framework into the Readiness Navigator software and did so in collaboration with Inits. I mentioned them before. So they're an incubator turning research from Vienna's universities into startups and other corporations. We released the software in 2019. And now I want to provide you a few more details about Hasnauer et al.'s framework to manage innovations. And basically, what we have here is more of a deep dive into market readiness. So what Hasnauer did is he split up market readiness in 4 sub-readiness levels that you can achieve for your product. And the first one is the so-called competitive supply readiness. And basically what the readiness levels here ask to be on these levels is, have you done a competitor ranking? Have you done an IPR rankings? You know who has which patent? Did you do a tech ranking, so you know who has which capabilities and where can you go? There's also the concept of demand readiness, and this demand readiness is posing questions about what level of demand is there for this product. So is the need actually specified? Is this quantifiable? Do you know what and how much of it do need to be provided? The customer readiness is basically a view of how ready are your customers to adopt your product. So different readiness levels that your innovation project can have is having established market feedback, identified friendly customers, or actually sold the first product. And lastly, the product readiness poses question about whether you have identified your market segments, actually specified the product options you aim to sell, and have your marketing plan developed. So these are the details about the different market readiness levels by Hasnauer. And there are also the technology readiness levels, which he also split up into 3 individual sub-levels that frankly sometimes get overlooked in innovation and technology development projects. And the first one is the intellectual property rights readiness levels. So in order to achieve high readiness levels here, you have to protect your own IP, but what you also have to do is to ensure your own freedom to operate. And freedom to operate basically means to make sure you don't infringe on somebody else's patents or other law relevant in your target market, so that you can actually do what you aim to do. There's also the integration readiness, which can be read as, how far along are you in specifying and implementing the interfaces you require to integrate your technology with the technologies you aim to work together, and the manufacturing readiness. So besides the availability of the product itself, the manufacturing readiness basically specifies how good and well your manufacturing process is, and if you can actually produce what you aim to produce in sufficient numbers. A good example we had here in Austria was a COVID-19 vaccine in the beginning of last year. So it was, we were able to produce it, but we didn't have the necessary quantities. So there was actually quite a shortage. So in this readiness levels, manufacturing readiness would have been too low for actual adoption. And one quote I often like to share about this is, wow, this technology can do anything except leave the lab. So you can leave the lab if you have high manufacturing readiness. Great. So this is Hasenauer's different readiness scales, which we packaged into the Readiness Navigator. And here just a few screenshots from it. This software provides users with knowledge about successful innovation processes and enables investors to rate innovation projects. We have a little bit of an example here, and this example project has a technology readiness of 2, which seems quite low, given that it has a manufacturing readiness of 8 already. So they really figured out how to produce their stuff. But the overall technology readiness is always the lowest level of all available readiness levels, because they have not yet figured out anything or very little about their intellectual property rights management. So the rating for technology readiness is quite low. And similar to the market readiness levels, you see here, you have different scales, but the lowest scale is 3. And well, that's the overall market readiness level you get. What the Readiness Navigator does is that it provides you a few tips of how to increase your readiness levels, and so which areas to address. And actually the readiness levels are stage gates showing if you have done certain things that are required to reach these readiness levels. And so this allows you to visualize how far along your project currently is, and well, you give hints on how to increase it. It's also customizable, which means you can disable some of these metrics that are relevant for specific innovations and basically adapt it the way you need to. A few more screenshots you see right here is basically a mapping of innovation projects throughout time. Well, here's only on the right-hand screenshot one point in time, but you see this project example we also had previously. Was currently at technology readiness level 2 while being at market readiness level 3. And what you see here is Hasenauer's ideal progress bar, and what it basically shows where you want to be or not too far away from it. And this means, okay, and the next steps you should do in this project, we're actually quite close to it. It's okay. But let's focus a little more on market readiness increasements and on technology readiness increasement. And well, this also enables the management of portfolios of innovation projects. So you can see how far along different projects are on these axes. This is actually something that all the startups that are helped by INITS have to go through, because they provide them with investment money, and they also are evaluated using this methodology and all mapped within the navigation software to see, well, how far along they are and what to do until the next report point in time. All right. So this is the Readiness Navigator software packaging Hasenauer et al.'s framework. And this talk is also about artificial intelligence and machine learning. And as you're all very smart people, I'm pretty sure you know most of the stuff I'm going to say right now, but I'm going to repeat it anyhow. So we are all on the same page. And what I want to tell with you is a key distinction between classical programming or algorithms in comparison with machine learning and artificial intelligence, like marketing people also like to call it. And what you see on the one hand is basically a programmed algorithm, which has been manually created by a human being. So you have an input and you have the fixed set of instructions that were programmed by a smart guy or girl or person. And this provides an output that you get here. And well, in machine learning, it works a little different. So this is a supervised learning model. There are other models, and one can go into endless detail here. But the gist is you have a machine learner, which in itself is actually a sort of algorithm that has been manually created. And this machine learner is provided with an input and an expected output that it should produce for this input. What it then generates is a model that could, in some cases, give feedback to a machine learner. And this model takes an input and provides an output to work with. And well, one might pose the general question of why should one do this? Because there are certain problems for which we have not yet figured out the good algorithm, but it seems that we can train models that are quite decent at solving these problems. All right. So having this in mind, we looked again at the readiness levels of the Readiness Navigator and identified a small gap. And this gap basically was that the manufacturing readiness levels express how ready a factory is to produce physical goods. This is all nice and well, but in the digital data economy, you have a few other questions that you have to answer, especially for AI and data science-based innovations. And some of those issues you run in such projects is a lack of labeled training data that you can use. Also issues about the legal data usage. So can you actually use the data for what you want to do? There is, well, there are legal frameworks in place. Here in Europe, we have GDPR, and this can mean that you, well, cannot do everything you want to do with all the data you have. You can also have the issue of skewed or biased training data. If, for instance, your training data models the real world and has sexist behavior in it, a model trained on this training data will pick up this sexist behavior and reproduce it. You have lack of explicitly modeled knowledge is an issue. What this means, I will talk about later. And also you can have issues in the area of precise problem specifications and efficient and effective algorithms for generating models for the kind of problem you aim to solve here. So having this in mind, we saw, okay, for innovations in this space, the readiness levels in the technology readiness, especially the manufacturing readiness, were not very useful. And therefore, we adopted, well, we wanted to have additional readiness levels for this kind of stuff. And to get them, we began with literature research and looked into existing readiness models for AI. And what we found first was something provided by Intel. And what we have here are three different aspects that an established company can have with regard to artificial intelligence. And the first thing Intel refers to as foundational AI readiness. This can be read as, does your company have the necessary hard and software to benefit from artificial intelligence? There's also the operational AI readiness, which can be seen as, is your company managing its data good enough to actually create value from it, as well as the transformational AI readiness, which can be read as, how ready is your company actually to maximize value obtained from AI? You know your business models, you know how to do this. There are three levels that have been defined by Intel. And the first one is that your company is new to AI. The second one is it's ready to scale up AI. And lastly, your company is already broadly implementing AI. All right, what we also found was a model by Capgemini Consulting. And what they did is they assessed different geopolitical regions in regard of AI readiness. And the first thing they looked at was institutional AI readiness. So what does this mean? Well, are your country's institutions ready for AI? The second one is IT maturity in general. So is everybody still running Windows XP, or are the IT systems in your country actually mature enough for AI-based systems? And lastly, the available IT skills. So is the workforce in your location skilled enough to do what needs to be done in order to obtain all the benefit you want to have from artificial intelligence? And these are nice and interesting models, and actually quite useful if you want to assess established companies or geopolitical regions. But we want to assess innovation projects. And for them, those levels, well, are besides the point. So what we did then was we took the existing Readiness Navigator levels, looked at what they actually modeled, and then took a lot of literature in the area of data management for data science projects. and extended the Readiness Navigator model for AI readiness and data readiness levels. And what those are, I will tell you right now. Similar to what Hasenauer did, AI readiness is not one scale, but a combination of two individual subscales. And to measure how ready an AI innovation is, we define the specification readiness levels. And this poses question in the area of how well the task is defined. Do you know the relevant business process for which you want to work? Are success criteria known? And how do you want to integrate your solution there? There's also the algorithmic readiness, and what we understand as that is if the underlying principles for creating a model in this field are identified. There are many different families of machine learner algorithms. Do you know which one you want to use for this task and which one is actually relevant and reported good results in the past? Yeah, and so on and so forth. But these are the areas of AI readiness. We identified two subscales for it. And what we also created were the data readiness levels. And here we have 4 individual subscales that can be relevant for an innovation project in this space. The first one is actually data existence readiness, which is quite straightforward. So does the necessary training data actually exist? And if it doesn't exist, how ready is the necessary data gathering technology? Do you have the sensors you need to pick up what you require for your solution? The next one is data format and quality readiness. And we read this as how well do you understand the existing data format? And do you actually know about relevant quality criteria and have information about the bias within the data? Do you know how to look for this bias? How can you measure it? There's also the legal data readiness, which surrounds issues if you can use the data, but also if you have to be able to explain the results you obtain, because something that's also hidden in the GDPR is the right to explanation. As a European citizen, you always have the right, if you are personally impacted by the results of an algorithm or model, to demand an explanation of why this was decided this way for you. And this can be quite tricky because many machine learning models are opaque and you cannot really look into it. And this gave a strong boost to the field of XAI or explainable AI, which well, is a research field of figuring out how to make machine learned models explainable. And the last thing is the expert knowledge readiness. And this is actually quite important for such projects, because usually you want to create a meaningful solution for your customer. And if you want to do something like that, you should identify what expert knowledge do you want to capture for this solution. They are quite famous, commonly available data sets, like, for example, ImageNet for image recognition. And you can train a model to tell dogs from cats using this data. And that's quite interesting, but that's something a toddler can also do. And what you require here is actually expert knowledge that you want to encapsulate. And experts can do so for such projects in 2 different ways. The first way is implicitly by labeling training data. So this expert, for instance, something that's commonly used is tells a melanoma from a nevus. Nevus is what I have here in my face. Yeah, such a dark spot on your skin. And so you see it's skin cancer, or it's not skin cancer. So in this case, the expert would be the doctor implicitly labeling such pictures in order to create a model later on. Data could also be explicitly provided, and this is by, well, writing down what you know in a machine readable fashion so that it can be integrated in a solution and be worked from there. All right, and the scales we have for expert knowledge is actually, do you know what knowledge must be captured, and do you know who will provide it, and how willing are they to provide you with this data? Because that's actually a very common problem for such types of problems, that you always start for sample data, and it's quite difficult to get the expert knowledge you require. All right, so these are our readiness levels for AI and data. And what we also wanted to share with you is how we can use state-of-the-art NLP and AI methods to coach innovators, and talk about our AI extension for the Readiness Navigator. And what this is, I will come to it in a minute. First, again, a few core definitions, and I wanted to share with you the fundamental approaches of how to build an AI. And actually, AI is quite difficult to define as a term because as of now, we have not really figured out what intelligence is. So making artificial what we have not figured out is a difficult definition. What's oftentimes used is that intelligence means there is an agent creating or performing intelligent decisions on its own. But again, you have intelligence in the definition of intelligence. However, there are different approaches of how to make this artificial. And the first and oldest approach are so-called rule-based AIs or also symbolic AIs. And this is basically expert writing down rules and having an algorithm interpreting these rules so that something like an intelligence behavior emerges. The second approach is machine learning based, and I talked about this previously. So we have our labeled example data or also not labeled example data and automatically generate a model. And this model is then used to do amazing things. There's also the neural symbolic integration approach, which is a combination of both. And just for completion, rule-based systems were called symbolic AIs, and machine learning-based systems were also called sub-symbolic AIs. All right, so I was talking about NLP earlier. It's for natural language processing, and it's a field of machine learning that deals about processing texts in a meaningful way. And those texts were written, well, by a human being for a human being originally. And one of the common tasks that you can do with them is a so-called text categorization. Well, it is what it sounds like. The task is to create a classifier, and a classifier is actually a function that maps a set of documents to a map to a set of categories using a binary matrix. And what you have here is, yeah, basically the expression, okay, this document is this. Common use cases for this are sentiment analysis. So it's something that's written about you on Twitter, positive or negative. That would be a use case. But another use case might also be, is this tweet actually about you if there is no hashtag? So figuring out, are people talking about me or are they not talking about me? This could also be done by text categorization. If you use machine learning to create a classifier, you have this concept of a target function that looks very similar because the target function is a humanly provided example to train the classifier. Another common task is the so-called named entity recognition. Named entity recognition is the finding of instances of classes, like, for instance, names, companies, or locations in a text. If I would take the entire text of this presentation and run it through a named entity recognition engine, we would get the companies SAP, Inits, and Ontek, just for example. A slightly more complex task is that of open information extraction or just information extraction. And what you do here is finding triples of subject, predicates, and objects in text, and basically using this form of semi-explicit knowledge later on in the downstream processing part. What could be done here is, for instance, finding out that SAP develops software as an SPO triple from some point of text that you processed. All right, so this is our basic toolbox that we can use for the Readiness Navigator. There are other NLP tasks that you can do, for instance, finishing a prompt that you start somewhere or artificially generating text on some kind. We don't require this later on, so I have not mentioned it here. And what I show to you now is a very high-level architecture slide of how we aim to combine the Readiness Navigator with this AI component to provide a meaningful output to innovators. And what we have here on the right-hand side is actually the Readiness Navigator innovation readiness model. And you see the market readiness and technology readiness. We have not included data and AI readiness because we ran out of slide space. But well, as it's configurable, it can actually be added here. There's also a text mining component that interacts with the file share. The aim here is to gather evidence from files, whether or not a certain readiness level might have been reached or not. More details about this later. And in order to ease the usage of the interface for innovators working with the readiness level, Readiness Navigator, we also envisioned a conversational AI or chatbot that cooperates together with the innovator and takes information from the readiness models, the text mining output, and actually the feedback the innovator provides by typing into it. All right. Now let's go to the text mining component in a little more detail, because as I've mentioned earlier, it analyzes text in a file share. And what we have actually done here is model this as a series of text classification problems. So what it basically does is deciding if all the content in this project means that a certain readiness level has been reached or not. And we experimentally evaluated this in a prototype that we created together with Professor Hasenauer, who came up with this readiness levels in the first place. More details about this later. What we also have is our chatbot. The idea here is that it takes the output of the classifiers and from the text mining component and poses questions to users like, I have read in this file that you filed for a patent application. Is this actually true? Or I read here that you rank your competitors, or this looks like a competitive supply ranking. Have you really finished this part of your market research? And based on the answers, a user provides here, yes, no, maybe, appropriate readiness levels for the project can be applied and next steps can be suggested. Okay, I talked about the text mining component because we actually prototypically implemented it and had the luck that we had access to 514 innovation project documentation snapshots. What we had here are not actually 514 different innovation projects, but fewer over time. So the same project was there at different stages, and in different stages, different readiness levels were reached by this project. The data sets were provided us in 3 different batches across 2 natural languages. So the first batch of project definitions, documentations were in German, the second in English, and thirdly, we also got another German one coming up with these sums of projects at different technology and market readiness levels. And what you can see here, this is not equally distributed. And there are some examples that are, or levels that are completely without an example. For instance, all the stuff here had no technology readiness level or 1, 8, and 9. So basically it was all still very much in a development phase and not yet ready for a market. Similar market readiness levels were also, well, there were examples for every level, but quite a few for some of them. And it was mainly concentrated around levels 3 and 4 for most of the projects. And well, how did we get to this? As mentioned before, Professor Hasenauer, who is actually the chair of high-tech marketing here at the University of Economics in Vienna, was collaborating with multiple startups and established companies on innovation projects, and yeah, had access to these project documentations for research purposes. And well, it's actually a little older data, so it was not up to date when we were working on it, but a few years passed. But this doesn't really matter because we could still use it for experiments. And Professor Hasenauer was so kind as to label these project documentations with their technology and market readiness levels. And well, then we took this stuff and performed the training and evaluation using an n-fold cross-validation process. And what this means, well, I tell you in the next slides. All right, how does this text mining process actually work? Usually when you do something like this in general, you start out with phase 0, which is basically a text extraction part. What this text extraction means, you have different types of file and data formats and want to get the text from it to continue working. This is followed by a feature extraction phase, and yeah, almost all machine learning algorithms are actually defined on numerical vectors. So everything that such a tool can learn from numerical vectors and not texts. So what you want to do here is transform a text into numerical vectors that a system can work with, and there are different kind of models and algorithms can be used for. Another important phase that's commonly mentioned in literature is feature selection. And what you do here is selecting for the most relevant features that you actually want to use later on, because some of them can just be noise, and selecting for the good stuff, yeah, well, it increases the effectiveness of the solution you're building. And this goes then on to the actual machine learning that you have here. As I've mentioned, you can use different models and algorithms for each of these phases. And one instance for a model would be in phase 0, OCR, for example. So the optical character recognition is usually not implemented by hand. So all the stuff has been trained, and you have a model that transforms a picture of text into actually text that can be processed downstream. You could also have approaches that span multiple phases, like, for instance, feature extraction and feature selection. What you commonly do is something that's also referred to as representation learning. And yeah, this is basically a way to create a model that very well represents the text that you have before for downstream processing of another problem type, like text categorization. And well, our setups that we have right here, and I just saw in the corner of my eye that we have a few messages in the chat. Unfortunately, I cannot see them right now, but I'm very happy to answer any questions after the talk. So our setup for this text mining component I was talking about earlier was that in phase 0, we just used Microsoft file types, so the document and PowerPoint files and also PDF files, and only the flat text from them. So we had limited time and did not implement some OCR or other interpretation of images you have there, just the flat text that can be easily extracted from these files. Sorry. After that, we created a combined phase 1 to 3 system that was actually learning terms and phrases that are most representative for specific readiness levels. And this was done for a reason, because it provided us with giving explanations of why the system thinks something belongs to this readiness level or not, because, well, it spotted these relevant terms and phrases within there. And now let's talk about the evaluation process a little bit. So I think we are all experienced with the pandemic by now, so you might know these terms already, but what you see here is a general confusion matrix. And this confusion matrix is a comparison between the actual values, so what reality is, and the predicted values by whatever is predicting it. In our case, a text classifier, or it might also be a corona test. And what you have here in this confusion matrix is if the actual value is positive and the predicted value is also positive, you get a true positive. You can also get false positives, false negatives, and true negatives. And you can do some interesting statistics on this, and each branch of science has its own name for these, but in text categorization and NLP research, you usually call this precision. And precision is the ratio between true positives and false positives. So you get this percentage, and it tells you how much of the stuff that you have assigned to a specific category or readiness level actually belongs there. The next value you can look for is recall, and recall is a measure of how much of the stuff that you want to have in this category has actually been found here. And yeah, those are conflicting goals that you have, because you can very easily have extremely good recall by building what's called a trivial acceptor. Having something that just allows everything into a certain category will automatically get you a recall of 100%. But yeah, your precision would not be very nice. On the other hand, you can also create something that is very, very precise, and the system must be really, really sure to assign something there before you do it. But in that case, recall will suffer. Therefore, you have a combined measure of how to work with this. And one that's commonly called for is a so-called accuracy, which I'm not a fan of, because accuracy is a measure that takes true negatives into account. And if you have too many categories, you easily get a lot of true negatives, because if you have, for instance, 9 different readiness levels, therefore 9 different categories, and you still make one mistake, you assign it wrongly and it should be readiness level 2, but you assigned it to 3, you still get 7 times true negative because you did not also wrongly assign it to all the other levels. So accuracy for a multi-class categorization problem easily is very high. Therefore, we use something different, and this is a so-called F measure or F1. And this is actually the harmonic mean between precision and recall. And yeah, that's all nice and good. And if you participate in a challenge on Kaggle or do something for a research conference where some competitions are happening in this field, you usually get a training set provided by the organizers, and then you train your model, which is later evaluated against the evaluation sets that they provide. And yeah, in the real world, you really don't have that. Therefore, we use the n-fold cross-validation, and here n is actually a natural number, for instance, 3. And what you do is you train n models with using disjoint different data sets and evaluation sets. So it looks a little bit like this. For the first model, if n equals 3, you take the first 2/3 to train and the last third to evaluate. Second model, you take the middle third for the evaluation and the remainder to train. And well, the last model we have right here. And then you can average and also select for the best model for what you want to do. All right. And using this process, we obtained some results for what we wanted to do. And this is assigning readiness levels to project documentations. And what we first tried was to train one model with 9 levels each. So we had a market readiness level model and a technology readiness level model, and each knew 9 different levels that something could be assigned to. And yeah, we ran it. And what we had here are the results in micro average F1. Micro average is just an approach of how you do statistics for multiple categories. I can go into details later, but basically what you see here are the F1 values of how precise and recall-ly the tool worked. And what we saw here is, well, it worked best for English. It seems to be an easier language because we had market readiness and technology readiness level assessment at 73% F1 or 61% F1. We also made a mixed batch, so we mixed German and English project documentations and trained it all. And here we still had 47% or 45%. We believe, but cannot actually verify it, that the lingo of market research and technology development contains many anglicisms also in German. Therefore, yeah, we can create a multilingual project model. So yeah, these results are actually not that overwhelming. If you would have just guessed, you would come out at F1 of 11% for 9 category levels. And well, it's significantly better than this, but also not great. So what's the usual go-to approach for machine learning projects is, if your results are not good enough, is to gather more data and train again. This was out of the question for us because, well, there were no more innovation projects that have been labeled, so we couldn't gather anymore. Therefore, we thought, okay, what can we do instead? And tried to create a committee of 9 models, which each had 2 levels each, instead of having one model for 9 levels. So you have 9 individual classifiers, and each one says, okay, this is market readiness level 1 to 9 or not. So it's level 1 or not level 1, level 2 or not level 2. And based on all this information they provide, it's all fed into a combination committee, and we get an overall result. And then we trained and evaluated this whole thing again with a combined data set of German and English. And this boosted our F1 values to 70% or 87% respectively. Unfortunately, we didn't have the time left to repeat all these experiments for the individual data sets until we had to publish. And therefore, this is where we stand with the experimental results on this text mining component. So what it does is, well, market readiness is assessed with a 70% F1 value, and technology readiness with 87. And it's actually not that bad because humans also make mistakes in, well, they're usually at about 90%, but for technology readiness, we are close. And also for the entire setups that we envisioned, it's not that bad because the underlying chatbot component is actually supposed to pose a question later on. So, okay, I saw here that you did something that looks like a patent application because I saw this, and this phrase. Did you actually do so? And by answering yes or no, you get your definitive information about this level. And therefore, yeah, for what we have in mind, this is good enough, even though not perfect. All right. Just really quick, I wanted to talk a little bit about what ONTEC does in the field of AI services. As mentioned, we are an individual developer and do not have the one product that we sell to our customers, except when we do, like in case of the Readiness Navigator, but this is actually a joint venture within it. And so our services in the field of AI and machine learning is in the first part is we do use case discovery, which is the identification of, well, a good use case you could do with machine learning for the customers. And these can also be loosely mapped to technology readiness levels as defined by NASA. And well, we do proof of concepts, prototyping and development. And in the end, we also have an operations branch that does not only do the hosting, but we also aim to do fitting for drifting models. In the case of natural language processing, this means, well, the meaning for words change over time. Right now, booster has quite a different meaning than 2 years ago. Therefore, we look for models to stay relevant for shifting environments. And yeah, this is basically what I have prepared for today. Therefore, thank you very much for your attention, and I'm happy to take your questions.
So thank you very much. So we don't have many questions, but I have an idea what to do. So let's go through the questions we have. First question: it would be interesting to see the results when running through the Theranos documents.
Okay, yeah, I don't know what Theranos documents are.
Me too at the moment, sorry. Next question from myself, how you would deal with subjective perception. So if someone says, I have the best data ever, and does not know what the quality requirements for a specific use case and algorithm might be, how do you deal with that?
Well, actually, the way the Readiness Navigator works right now is that you have multiple people that are invited to perform an assessment of the innovation. And so what we commonly do is actually do this in type of a workshop together with those people. And what you get there is multiple points of views of how ready something is. So for instance, in this data, yeah, if the best data is what one person thinks. We aim to not only ask one person, but multiple persons. And in the end, you have the project manager that's responsible for this innovation in some sort. And this person has to finally make a decision which level it actually should be. And this one is assigned when using with the Readiness Navigator. And well, for the machine learning part, well, a model is only as good as the stuff you train it on. And this is actually modeled in the data quality readiness levels that we created of, well, how much experts do you have and how happy are they with sharing it? So yeah, I talked quite a lot about this right now, but I don't have the definite answer, just that we ask multiple people for their point of view of where something stands and combine these results.
Okay, you might go back to the slide for the recall and precision formulas. Then, because there is a comment, it might be wrong, but maybe someone didn't see the difference between FP and FN. The formulas are correct from your point of view?
Yeah, I think so.
Yep. So there is difference between FP and FN. So next question. Other than e-discovery, where can we use text mining?
Where you can use text mining? Well, for quite a lot of different ideas you want to implement. So first question is, what do you want to get from the text? So there, I've talked about this earlier as a sort of a little toolbox of what you can do in this area. And you might want to extract information from available text data to do something with it, or you might identify specific entities within it. And it really depends on what you want to do. I, for instance, had a project some time ago that was scanning through real estate offerings and looking for specific stuff that is offered in them or that's not offered in them. So what you usually do here is that you go from the business point of view, if what do you want to do? From there, you go to the data point of view, which data do you want to analyze in order to obtain this? And then you figure out, okay, how do I best model it and go ahead to get the information out of it? So yeah, your fantasy is your limit, or the idea for the business case that you want to implement.
Okay, thank you. Next question is a refinement of our first question, that it would be interesting to see running through Theranos documents. Additionally, question, does it protect from fraud from startups like Nikola, eTrucks, Theranos, blood sample from Fingerstick, WeWork, etc.?
Well, a definite maybe. What you get here at least is that you see how far along you are on your projects. And actually, we have not looked into the identification of fraud within startups. This has been out of scope here, but yeah, maybe you'll find interesting patterns here, because I think fraudulent behavior could be skipping relevant steps that you should do to get somewhere and just pretending to have done so. And that might be either stupid or fraudulent, I don't know.
Okay, thank you. Next question. Any ongoing research related to text mining applications?
Yeah, sure. So we are currently in an open information extraction project. The difference between open information extraction and information extraction is that for information extraction, you have examples for SPO triples that you want to find, and open information extraction is where you don't have examples and go out into the open space and try to leverage transfer learning. And transfer learning is basically the idea that you try to learn from one stuff and apply this stuff to something completely different, and still go ahead to mine vast areas of text that are available. So this is what we are working on. We have a little bit of internal research, but as we are only 60 persons in a service company, well, this is what we do, but there's also a lot of ongoing research from academia in this area. So NLP is currently exploding. There's a lot of stuff here.
Okay, thank you. There is at the moment no more question in the chat. So an idea from myself, might it be possible to see a system running an Ontech navigator opening?
Oh, again, a definite maybe. I hope I still have a login for it. Wait. I think I'll just quickly stop sharing my screen and try to get you there. Sorry, I cannot really promise that it's going to work. Poorly prepared, I have to.
No worries, just an idea to see the system once, maybe to get a feeling of what it is, and if it doesn't work, don't mind. Meantime, people, you can type in more questions. If no more questions come in and the potential demo doesn't work, then we could.
Yeah, I'm very sorry about this. But,
no.
I'm actually the AI guy here and not the readiness guy.
Yeah, okay.
But we collaborated with the readiness guys. So,
readiness for readiness. Yeah.
Yeah, readiness for readiness. But actually, I'm in luck.
Okay.
So I'll try to get it to.
We have 6 minutes
again.
left.
Yeah, should be fine. So, okay, I hope you can see my screen, which should just have a browser and a login, and the Readiness Navigator is actually implemented as a web application, meaning that you just need a browser to use it because, well, that's not that hard to do so. And there's actually a community edition that you can log in for free as of now. That's the online edition of this, and I have my account here from former projects. So what you get here is an overview of the projects you are currently active in, and can filter for different areas of industry that well, the order from where the project stems and which it targets. And if we go in here, we have the different milestones at the ratings of where we are. And at this first milestone, we, well, had quite low ratings, as one can see. And I don't know. It's been a while and I've not been actively using it. So this might not be the best one, but if we zoom
it gives people an impression of what we're talking about here. Yeah.
There was also this other view of which I made a screenshot for you, but I just cannot find it right now. Ah, here it is. So yeah, that's actually everything is quite low, but this is the official rating that the project manager did, and I'm an optimist by heart. Therefore, my rating was much higher, and this goes a little bit to what we were talking about earlier. So if somebody says he has the best data of everything, and I said, yeah, we were actually very ready and very prepared, and actually we were not. And so you have this combination right here, and you can also go ahead and aim to rate the technology readiness level that you have here and figure out, okay, what is it actually supposed to be? So you have a few hints right here, what you should do to get this place. And this is actually the early Readiness Navigator community edition we have here. You can just sign on to it. Just visit ontech.at, and there is a link there under our products subpage. And yeah, go ahead and rate your products, your innovation projects. So this is it.
Okay, thank you very much. So there are no more questions. Quite informative. Thank you very much for being here and doing the presentation to us. Thank you to everybody attending. As there are no more questions, nothing to show, I would say thank you, see you next time, and goodbye.
Yeah, thanks you all for having me. Thank you. Okay, Michael, das war's dann, oder?